Alright, video 3. It's a little bit different set point on the oscillator. Actually results in the minimum amount of input current from the batteries, from the supply. Hook this up. Let's see what happens. Cathode's on the left. See some bubbles come up off the cathode there. Some foam accumulating around the top. These bubbles are extremely fine, very, very tiny. There's just a little bit evolving on the anode, and just a stream of fine bubbles coming up from the length of the cathode there. In the previous video, that cell's actually being driven fairly hard at a different set point on the oscillator. If the power is removed from the circuit and then reapplied, I will have to detune or retune the circuit to get the oscillator to start back up heavy and gas to evolve. This particular set point here, power can be removed and reapplied without touching the tuning or tweaking the tuning whatsoever on the oscillator. It starts up just by application of the power. Significantly less gas evolving from the electrode, also significantly less current in, which I believe this is probably the set point that I'm looking for. Very, very low power input. The other is driving hard. It develops voltages across those electrodes that are in the neighborhood of 2 volts across the electrodes instead of you stipulated 1.4 roughly. And I've read some other papers that are calling for that particular point too, specifically in the for thermal reasons. So here's another spot on it. I'm exploring it, and you can see I'm exploring and modifying my exciters as I go. Let's see if I can get a better shot of this. Yeah, you can see the foam there. And I'm sure if you hear some buzzing in the audio here, crackling, that's pretty much I can't get it out of there. It's my exciter making a racket in the audio. This is being recorded on a PC with a webcam and a web microphone, so it's by no means studio equipment, but it gets the point across. So we're rolling up here in Yankee Land. Thanks a lot. Talk to you later.